So hello students, we are here with our next question. The next question is, let S be the set of all integers n such that, see, what are we given? 8n cube minus 96n square plus 360n minus 400 divided by 2n minus 7 has to be an integer. This is the only condition. How many such n are possible? See, if you look at this statement in totality, it's really very difficult to find the condition, but one very basic thing which if we apply, the question turns out to be a very simple question. What does it? See, the numerator is of degree 3, denominator is of degree 1. We can of course go for long division method. So let's go for long division method, because in that case remainder will be a constant, okay, because we know the degree of remainder has to be less than the degree of divisor. So if you do it patiently, this seems to be a bit typical because of maybe the numbers which are given in numerator or the dividend, but still if we do it, okay, so 8n square, so that's simple, 8n cube minus 50 4n square, 4n square, so minus 28n square, so minus and this is plus. So what are we left with? So 28 means 26, so it's 68, isn't that? Minus 68n square plus 360n minus 400. So now next one will be of course minus 34n. So it's minus 68n square, and then it is 7, 210, 238, and this is plus n. So again when we subtract, so this is nothing but 122n minus 400, okay. So now we need here in the question, what do we need? In that case 61. So it's 61 means 122n minus 61 means 427, okay. Now see, what was actually expected? We got remainder as 27. So what do we have? So we have, therefore the given expression can be written as quotient, which is 4n square. See, whatever it is, for n to being an integer, this is of course going to be an integer. It won't bother us. So what's the only thing left with us is 27 divided by 2n minus 7, and now we have to just ensure that this is an integer, and that finishes the question itself, isn't that? We have very few possibilities for this to be an integer. How come? See, 27, the factors of 27 can be 1, 3, 9, 27 with plus or minus 1, because it has to be an integer. It can be positive or negative. So it's simple, 2n minus 1 is plus or minus 1. So that gives us two values. So if it's minus 1, n is 3. If it's plus 1, okay, then in case n is 4. Similarly, if it can be 3 or maybe minus 3. In case of 3, it's n is so 10, so n is 5. In case of minus 3, n is 2. Why? Because it will be 4. Isn't that, bachcho? Yeah. Or it can be 9, in that case it's 16, so n is 8, and it can be minus 9, in that case n is 2, so n is 1. Or it can be 27. 27 means 34, so n is 17. Okay, or it can be minus 27. In that case, it's minus 20, n is minus 10. I don't think we have more such possibilities. So 4, 1, 3, 9, 27 plus 1, no, yeah. So let's add them. What we need is sum of all these mod. Okay, so 10, of course, mod 27, and then 27 is 35, 36, and then 36, 38, 42, what are they? Yeah, 7, 12, 14, 22, 23, and then 40, 50. So hence the summation is nothing but 50, and that's the answer. Simple. Once we get this idea, bachcho, okay, so the purpose behind taking this question was to have this idea using long division method, and then we can easily do it. Okay, so that's it.